Okay, what about the one following that? The 4.2 to the x equals negative 7.1. That's an exponential as well. Okay, third row, first equation, the log base 2, 1. Do y'all agree? Do y'all see it equals 2 on the other side, so log equals number? Oh. What about the next natural log? Natural log of x minus 6? That problem? That's log equals log. And finally, that's an exponential, 7 to the 4x plus 1. And this one right here is probably the hardest equation to solve on this sheet. Okay, so our strategies from last time essentially said this. If you have an exponential equation, unless you want to be slick and use sort of that cheat that we talked about back in 4.2, where you try to get a common base, what I'm going to recommend doing that works for any kind of exponential equation is take either the common log or the natural log of both sides. All right? It doesn't matter which one, although if you have like a base e in there, I would strongly recommend using natural log because natural log cancels with base e. And if you have like a base 10, I would use the common log because the common log cancels with the base 10. But in most cases, the common log or the natural log isn't going to cancel with any of these. Okay? Like, it won't matter whether I use common log or natural log here. The only one where it wouldn't matter is I would say here, where I've got my base e. In this case, I would almost definitely use natural log, but that's the only one where I would be particular. Okay? The reason, I may have said this, forgive me for repeating myself, but the reason we want to take the log of both sides is in trying to solve for my variable that's in the exponent, it's difficult. So because I take the log of both sides, I've got that third property down there that lets me bring exponents out front, and it gets the variable out of the exponent and into a place where I can manipulate it using other algebra skills. All right? The equations that we're going to call log equals log, these are probably the easiest ones to solve. Okay? And the reasoning here is, if the log of this number equals the log of this number, then the two numbers should probably be the same thing, right? So we're going to look at the inside, set those equals together, and solve that. But because it's a log equation, we're going to have to check our solution. Like radical equations, it's possible that after solving our equation, we get something that isn't really a solution. This time what we're looking for is, does my solution require me to take the log of 0 or the log of a negative number? If it does, then it's not a solution and I throw it out. Okay? So finally, the ones that are log equals number, we're going to rewrite in exponential form. We start with our base, and then we do our exponent and all that, and we solve that guy. And again, we check the solutions for the same reasons. Okay? Let's start with the easy ones. Right? It's always nice to like baby step in. I don't know, it's your philosophy of how you like getting in the swimming pool. Do you like jumping in, or do you like tiptoeing in? I don't know. Let's tiptoe. At some point our privates are going to get cold, but we'll tiptoe first. So, solve. The natural log of 2x minus 1 equals the natural log of x plus 2. Okay. What I'm about to show you, I don't want you to tell another math person I told you to do this. It's mathematically embarrassing that I would even acknowledge that this might happen. But what sort of kind of essentially happens, if you skip 2 or 3 steps, what you end up with is, if the log of something equals the log of something, it's like the logs almost kind of sort of cancel each other out. It's like that. And I just end up with the 2x minus 1 equals the x plus 2. Alright, that's skipping 2 or 3 bona fide mathematical steps, but I think that's simple enough and safe enough shortcut that it's, I don't mind showing you that. You just don't tell anybody I told you that, right? Okay. So once I've taken the log off of both sides, holy cow, this is a really easy equation to solve. Ninth graders can solve this equation, like the good ones. All right? So we subtract off our x, right? We add our 1. I'm starting to rethink that statement. Can the ninth grader, did I ever get a ninth grader to solve that equation? I'm not sure. Maybe. So I get x equals 3, maybe. It's still only a potential solution. I have to check it. And I am not going to require you showing me the checking step like I did with the radical equations, but if you don't check it and you get a wrong answer, then you got the wrong answer, right? Okay? So as I check this, and I plug in my 3, so does the natural log of, what's 2 times 3? 6. Minus 1 is? 5. So does the natural log of 5 on the one side, do you believe that equals on the other side the natural log of, what's 3 plus 2? Okay, I may not know what the natural log of 5 is, but do you believe that the natural log of 5 is the same thing as the natural log of 5? Am I allowed to take, more importantly, the natural log of 5? I can take the natural log or any log of any positive number. Okay, as long as this isn't negative and it isn't 0, then I can do it. So it checks out. So x equals 3 is in fact my solution. Okay? So that was the warm-up.